Okay guys, welcome back. We're going to take this one up. This is Unit 4, Handout 4B, and it is question number 1. Okay, and it's the same as all the other ones. We're going to take our voltage and work it out so that we have our voltage across the load there. Okay, and then we're going to calculate I-phase load and work that back. So I'm going to do it, kind of quietly. Hopefully you're getting better at figuring this out. Okay guys, so E-phase primary looks like it's delta, so that's 700 volts, right? Across the transformer, that's going to be 700 divided by 4, because that's our ratio. So let's do that, 700 divided by 4 on the 75 volts here, okay? And again, it's delta, so it looks like our line voltage is going to be the same on the secondary side, 175 volts, and then this is Y, so it's going to take that 175 divided by root 3. Okay, guys, so 175 divided by root 3. Okay, divided by root 3. And it looks like we get 101, volts. And that would be measured here, right, guys? 101 volts, E-phase load. All right, guys? Now we have to calculate I-phase load. And again, it's a mystery load. It does have a power factor. It says it's 7880 watts. Now it's really, you got to be careful here because the current is not going to be the watts divided by the voltage, okay? Because that's, well, the watts is ER times IR. And we have the total voltage here for that load, and we're trying to figure out the total current here, which means we have to use VA, which means that before we calculate the load on this particular one, because I've given you watts and not VA, you have to calculate VA. Okay, guys? And this is 77880 watts, okay, with a power factor of 0.6 here, right? And so my VA, guys, should be the power divided by our power factor, right? 7880 divided by 0.6. Looks like this one load, okay, we're just looking at one of them, is 1313 VA, and it has some VARs too, which I don't care about right now. Okay, we could calculate it, doesn't ask for it, and we're not going to. But now that we know the VA, we can calculate the current. It's going to be the VA over E, and so it's 1313 divided by 101. All right, guys, and 13. Whoops, there's another 3 on there. Okay. Man, terrible. Okay, going too fast. 133. So we're going to hit divided by 101. Okay, guys. Just checking it out here. Sorry. Making sure I'm on the right track here. Yep, 130 volts, 130 amps. I'm just checking my homework off to the side here, making sure I'm not screwing up. I don't think I'm screwing up, but it's hard to do all this video and talking and calculating and thinking all at the same time. All right, guys, so I'm just trying to stay ahead of the game here a bit. All right, 130 amps, okay, and that would be, if I clamped onto any one particular load here, 130 amps right there. And now I'm going to take that current back. Looks like that is I-line secondary is also going to be 130, right, guys? I-phase secondary looks like I'm going to divide it by root 3. So we'll do that. Divided by, 130 divided by root 3, and that's because it's delta here. 75.06, I guess, if you want to get fussy. Cross the transformer at a ratio of 4:1. $18.7, 6 amps. Okay, that would be right here, right, guys? 18.76 amps. Right here was 75.06 amps. Right here was 130 amps, right? Now we're looking at this, and looks like that's feeding both, so it's going to be times root 3. 18 0.76 times root 3 times root 3. 32 amps, 32.5 amps right there. Okay, and I wanted to show you this one, guys, because a lot of students, once they figure out the voltage here, they go 7880 divided by 101 to calculate that current right there. But that's not how it works, right? E times I is VA, not power. That was only in level 1. Transformer kVA, as usual, guys, I'm going to calculate it 3 times. I'll do it quietly, okay? Okay, so I got those written out. I'm going to just calculate them. So far, so good. Okay, but we aren't sure until we've checked them all. Okay, guys, and those are all correct. And so are all the same. So I'm happy with that. Now, if I look at this number up here, guys, just for fun, this is the VA for one of the loads. So technically, if I multiply that by 3, it should equal that, right? So if I take 13133 and multiply it by 3, just for fun, as a quadruple check, right? 13133 times 3, because there are 3. 39,399, okay? Okay, so 39.4 kVA for all of them. All right, guys. Now, input kilowatts, I have a couple of choices. There's my kilowatts right there, right, for one of the loads. That's the output, but the input's going to be the same. So figure out your input kilowatts anywhere you want, okay, because it's not going to make any difference. There's a lot of different ways to do it. I could take this and multiply it by 3 if I wanted to. In fact, I'm going to do it 2 different ways, okay? I'm going to take it and multiply it by 3. So for K here, it should be 7880 times 3, because there are 3, okay? And that is the output kilowatts, okay? But it'll also be the input kilowatts. 7880 times 3. Looks like it's 23,640 watts, okay, guys? But if I want to, I can draw a power phasor diagram for this entire circuit and calculate it that way, because here's my VA for the entire circuits. It's 39, let's say 400 volt amps, okay, with a power factor of 0.6. So power should be VA times, power factor, all right? So what I did was I took the 39,400 VA from here, okay, power factor of 0.6. We're calculating the power here. It should be the VA times the power factor. So it should be 39,400 times 0.6. And that should come out to the same number as that, but let's find out. 39,400 times 0.6, okay? 23,640, Okay, so 2 different ways. Take your output kilowatts here, multiply by 3, because there are 3. That'll be the input kilowatts. You can also take your power phasor diagram for the entire circuit. That's the power phasor diagram for one load, right? This is the power phasor diagram for the 3-phase load. There's my 3-phase VA. Here's my 3-phase watts. All right, guys? And, your VA is the same here, here, and here, which means your watts are the same here, here, and here. All right, guys? I'm going to have to stop putting questions on the sheet this way, because, I'll see if I can do better. All right, guys, have a good one and enjoy your day.